Oh, I did. All right. Hello, we are the STEMists. We are from Irma Rangel Young Women's Leadership School, and our project is called LED Luminescence. So for quick introductions, I'm Ashley Ramirez. I'm the project manager, and I worked on managing and overseeing the production of the product, the portfolio, and the overall presentation that you're seeing right now. I helped in creating the overview for the basic content that would be included into, again, all of those things mentioned before. And I helped in the formatting, and I also helped in making sure everybody had what they needed to get their jobs done and had what they needed in order to ensure that this would go running smoothly. I'm going to go ahead and pass it over to Anna V. Escobar.
Hi, I'm Anna V. Escobar. I was the project coordinator. Essentially, I worked on the journal mainly and the writing portions, and I made sure that I wrote down what we were doing in each group and made sure that we were doing an assignment, and we got that assignment done in a timely manner. I will now pass it over to the research and marketing manager.
Hi, my name is Taryn Clymer, and I am the research and marketing manager. I worked on obtaining research on our topic and making sure that we followed this research.
Hello, my name is Knox Cleaves, and I am the creative design lead, which is designing the aspect and the 3D building. I programmed the 3D model using Onshape to create the team's model. I'm sending it back to our project manager.
So for a little more background on us as a team, I was approached by our leader, Ms. Clark, and I was approached to basically start this project and get a team sorted before this year's STEAM competition. I picked out these team members because with my knowledge that I had on us as like a friend group, I knew that they would be perfect for the roles that I saw, and I thought that they had the qualifications and the things needed to be like great for this kind of project. So that's really how we came together. So we all go to school here at Irma Rangel Young Women's Leadership School. We are all in the 8th grade, and we are all in the graduating grade of 2027. So Irma Rangel is a school for girls in Dallas, Texas, and it's part of the Dallas Independent School District. It is the first public all-girls school in the state and is renowned for its challenging coursework and its high college acceptance rate. So I'm going to talk a little bit about our challenge for this year's STEM competition and what exactly it was that we were assigned to do. So our challenge for this year's STEAM competition was to create a product addressing and dealing with the reduction of waste. So water waste, electrical waste, environmental waste, chemical waste, food waste, etc. And so our part of the challenge, so we chose to tackle the challenge of finding a solution to the current issue of electrical waste and light pollution. We did this because we realized that electrical waste and light pollution are big problems in the area that we live in and in general for cities like ours. And we wanted to try and come up with a solution for it. We did this because after really narrowing it down, we realized that like a lot of areas where we live and stuff like that, you can see that like light is one of like the biggest, I guess, issues and things that needs to be really addressed compared to like a lot of other things. Obviously, other wastes are as important, but because of where we live here in Dallas, we realize that it's one of the more bigger issues that needs to be addressed. I'm going to hand it over to Anna V, who will be explaining the procedures and the engineering method.
So essentially, we followed the engineering design process because it really helped us go through what problems we were dealing with, trying to find more information on those problems, thinking of some solutions, talking to some experts, coming up with a better solution, dealing with more problems, more solutions, and keep on going back and forth till we got the best example, the best prototype possible. So first started off when we were just coming up with problems to work on that we were really passionate for. Whenever we were throwing out different ideas, we started talking about mainly light pollution and different lighting issues along with electric waste. I remember one moment we were talking about turtles and the lights and the different lights used for turtles, about going to the ocean whenever they're first born. But overall, we stuck with light pollutions and street lamps that we could be more active in, as that's a problem in our current life because of our location. Handing it over to Taryn Clymer, who mainly did the research, which is the next step in the engineering process.
Hi, so I decided to start by researching our main topics, so electrical waste, electrical pollution, things like that. So when we first looked at electrical waste, we noticed that the lights currently used in Dallas are primarily high pressure sodium lamps, which are very expensive, energy wasteful, and inefficient to replace. We learned all of this from our first expert, who really helped us out with this. So these light bulbs use gases and electricity to produce light. These lights are vastly less efficient and require much more maintenance compared to LED bulbs, which is what we ended up deciding on. LED bulbs are extremely easier to program and to manipulate based on dimness, things like that. So speaking of dimness, we wanted to look at how we could dim the lights without it being a safety issue. So we looked at motion sensing. So we looked at how a motion sensor could determine a human mass farther away from the pole, closer to the pole, and how dim or bright the light needed to be when that human is near. We then looked at how the color of the light would affect the human. So we talked to our first expert, and we determined that amber lighting was the best for human eyes and had a good electrical waste reduction. We then looked at alternative energy sources to make sure that we came up with something for our waste part of this. So we looked at how solar energy can be implemented easily in Dallas streetlights, and how solar energy and creating a solar panel with a battery will help with the electrical waste in Dallas.
All right, so here on this slide, we're going to be talking about the different kinds of prototypes. So in our process, we went through many designs and many different ideas for what we wanted to do. Like Anna V said, we originally stuck with like turtles and how that lighting would work, but we, like they said, eventually settled on the idea of handling streetlights, as that's the one we know the most. So we had originally thought about just creating a whole new pole, like a whole new street lamp. Then after talking with a couple experts, we realized that the pole is the most expensive part, along with having to like actually dig it in and like cement it into the ground. So then we were thinking about a movable extension. So we solidified the idea of just adding on to the already existing poles that already are implemented into the ground and stuff like that. So as we came up with the prototypes, as you can see in the images, all the research that we did and all the designs that we did, we used our research to determine the possibility of certain aspects of our design. For example, we wanted to know, so we wanted a motion sensor. We knew we wanted that in order to control, again, the dimness and the brightness of the light, but we didn't know which type of sensor to use or where it would be placed. And at first it was similar to a camera placed closer to the top of the pole. We then, using experts' advice and other things, we discovered the use of infrared motion sensing and used a camera such as that was a lot closer to the bottom of the pole with a less obstructed view, as that would be better in terms of finding a radius for it to manage its light. So throwing it back to Anna V.
Okay, so after everything, we finalized our prototype with a cap to add on to the original pole. So it will, of course, reduce the cost, because like they were saying about the cost of poles and installing it with the electricity and rewiring it, it would be a lot more. So instead, having a cap would be less costly. And I would also just be able to tie into the power source and the power grid already. And this design basically helped to overall just reduce the amount of light pollution given outed in our area, and also the electric waste throughout like the actual electric grid and just type of the energy that we're using. And so a lot of these changes were changed because of our experts and the type of information that they gave us. So going more into detail about our actual design. So like I said, our design is a cap mainly, just to go on top of that original pole. It has a dome hood basically to prevent spillage of the light and to reduce the amount of light pollution that's given out into our area. It also uses LED lights to replace the high pressure sodium lights and replace the amount of management that they had to take, because they would break very easily, and a lot of maintenance would have to go into high pressure sodium lights, while LED lights don't require that. They also are just more energy efficient. And of course, the amber color to be best used for human eyes, as these lights would be mainly in populated areas. Also the usage of infrared motion sensors to reduce the usage of extra light, as they would probably be around 50 to 70% at nighttime. And then when motion is detected, it would go more to 100. We also use solar panels and a storage battery to store that energy, because the solar panels, of course, would create energy in a green manner from the sun during the daytime and save that energy in the battery, and then of course use it at night when the energy is needed. And it would also be connected to the power grid to, in case of a power outage or anything would happen, it would have a backup source. Leading on to Knox, who would go on their design.
This is our 3D model. It includes a solar battery and a motion sensor in the lower image, along with a solar panel, LED light, and light hood with a cutoff in the top 2 images. We sketched out the original design before starting to add some of our final details. To design this on Onshape, a high school use resource, which was taught to me by Mr. Stroud, I had to program shapes which had to be hollowed out so that it wouldn't use up too much of the filament. Our school's tech expert, Mr. Stroud, taught me how to use the program and how to develop our idea further. The process was tedious and required advanced computer skills to be able to accomplish this. I started with the light bulb, then worked my way down towards the pole and started finishing touches such as the solar battery, motion sensor, and solar panel. The 3D printer did not print the light bulb correctly, so we had to replace it with a cotton ball.
And
So-
if you want to get it close up.
Yeah, we'll stop screen sharing so we can see the thing. And then Knox, do you want to talk about the different parts?
So this is our 3D model, and this is essentially a cap that will go on top of the pole, as mentioned earlier. And this is the motion sensor, battery, solar battery, LED light, and the cutoff for the light. And then this is the solar panel that goes on top of the pole.
Okay, so we're going to continue screen sharing. All right, share. All right, so we're gonna continue onward. All right, so real world implementations. So if our design were to become implemented into real life, we hope and fully believe that it would be a great asset into managing electrical waste. With the additions that we added, not only will we be able to conserve more energy, but we will also be able to maintain it, as the structure would require less maintenance and of course last longer. And some of these features would include obviously the LED light, which would help in maintaining the amount of light, and the lights would obviously last longer. And once they were able to accomplish those jobs, if the LED lights ever were able to get damaged or were just finally it was their time to stop working, they would be less damaging in landfills, as they are more environmentally like safe and decomposable compared to everything else like other lights. Obviously the lights, they use less energy, they require less maintenance, and it also allows for us to maintain optimal safety while allowing for a controlled dim and brightening of the light in order to save the amount of energy that we're using, and just overall provide a better way of using light and maintaining it in our kinds of communities. So these are our experts. The first one is Colin Yarbrough. He is an engineer, advocate, author, researching infrastructure, environmental justice, and community resilience. He really gave us insight on the idea of what the color of the ray should be, like what the color of the light would be and how it would benefit humans. And he also helped us in the process of discovering and implementing the infrared motion sensors. Our second expert is Jordan Michael. So he defines himself as process improvement consultant on Encore Electric Delivery, which is obviously
Encore, a part-
Encore,
a
obviously
branch of Encore.
a branch of Encore. He gave us a lot of information specifically about the electric grid and how we would go about programming it. And he also gave us information about the benefits of adding different sources of energy and how it would help in decreasing that electrical waste and what would be the best route to take when approaching this kind of thing.
So a few of our thank yous. So we would like to thank our sponsor, Ms. Clark, for supporting us throughout this entire process, giving us advice and helping us fully develop our idea into something fully functional. We would like to thank Mr. Stroud for teaching us how to use Onshape and being able to 3D print our model, which otherwise wouldn't be possible without his help. We would also like to thank our experts for giving us information that we wouldn't have known, helping our ideas develop and assisting us as new ideas arose and new issues arose.
All right. So in summary, we hope that our design will reduce the amount of light pollution and electric waste in the Dallas area. And it will also help to ensure that people will be able to have street lamps that are working, since there are many old street lamps that are broken like around the area and they are just too expensive to repair. In addition, it will also spread awareness on the amount of light pollution and the electric waste being expelled from everyday items. We found that this is an issue that isn't really talked about as much as it should be, and we think that's very important to discuss. So these add-ons to our design will help into making sure that we reduce the amount of waste being produced. For example, the solar panels, they will help to ensure the conservation of electricity as they will reduce the uses of the electric grid, and it'll help us in obviously advocating for the use of alternative resources in the place of things like electricity or even like obviously fossil fuels and things like that. The infrared motion sensors will reduce the amount of electricity used by only using a percentage until motion is detected. This will help us in maintaining the amount of light and making sure that there's no excessive light being used. And the LED lights will obviously require less maintenance and provide more efficiency, which will allow us to maintain those lights for longer and make sure that they're environmentally better for both the people and everybody in the community. And that is all. So I will stop screen share. So that's it for us. We really thank you for taking your time to come and like watch our recording. So thank you so much. And we are dismissed. Yay.